2.3 is basically a recap of what we covered on Thursday and what the activity on Tuesday was supposed to lead us to. How in the heck do we display quantitative data? So I've given us an example here. We have scores from exam 3 for one of my old stats classes a year ago, spring. And we can see, okay, this doesn't tell us a lot. One of the things we could do is what a lot of the groups did on Tuesday, start grouping up these scores. Maybe all of the Fs, the Ds, the Cs, the Bs. And that's exactly what you see on the next page. Started grouping them in groups of 10. So 10 to 20, there was a student who managed to get somehow less than 20 points in that exam, and so forth and so on. So we don't have any real gaps here in terms of missing data, but we do have some pretty low data. If we sum up all of these values in the class frequencies, they should sum to our total number that we originally had. So I had 42 students in the class at that point, so there should be 42 on this table. Next we could do is go ahead and make a histogram. I had a typo here, ignore it. I'll talk about it in a second. So big reminders about that histogram. I said them all on Thursday, but I'll reiterate them now. 1, each of these bars, they should be touching, especially if we're dealing with continuous data. The bar includes the first value that it starts with. In this case, we're missing that 30, but we know what it is. And it does not include the final value in that range. I like to, whenever I have a histogram, put in all of the values along the bottom that are missing. Almost every stats program deletes those because we can infer what they are. But I cannot tell you how many students in the past have told me, oh, the lowest score is somewhere between 0 and 20, as if they didn't know that that little bar was at a 10. So that just keeps us from making mistakes. Another thing I do, most histograms don't have the counts along the top, so I'll go ahead and add those. And we'll see that in the one example we have in this section. What else do you want to say about histograms? The other way a histogram can be made, besides just having frequency here on the side, is what we call a relative frequency table. Relative frequency histogram. It's just like our relative frequency tables we saw in 2.1. So if I wanted to do this, instead of having 8 to all those numbers, I would just have 2 divided by 42, 4 divided by 42, 6 divided by 42, 8 divided by 42, whatever the heck those numbers are. And it turns out I did not bring a calculator with me. So hold on a second, I'm going to go grab one. Found my calculator. So I went ahead and green, gave us those percentages. And I just wanted to point out that this histogram looks exactly the same. The only thing that would change if we did a relative frequency histogram is that the values along the side would become percentages or decimals, proportions, and they would no longer be the count. But the actual shape of the graph will not change at all. So what are we supposed to be able to take away from this graph? Well, there's 3 things that we should be able to see. Center, spread, and shape. We talked about this in class as well. Which outcomes are the most common? So I know I have a space for this on the next page, but because of the way this video is going to work, let's just go ahead and answer actually each of these questions right now. So what outcomes are most common? Well, it looks like most of my students, I don't even know how to undo that. I had to grab the video screen again. Bananas. All right, we're just going to work on this. So most of our observations are in these ranges, right? The very most students got an A. In fact, if you lump the A pluses in, I had 11 students who got A's on that exam, which was the biggest group by far. So outcomes the most common, 90 to 100 is the mode. Our most common outcome for this. So like I said, the mode only really makes sense in this context of histograms or binned data. And then it actually does make sense. So our most common outcome was from a 90 to 100. What range of outcomes occur in the data set? Now, if you're using the histogram, you kind of have your arms tied behind your back here because all we can see is that the smallest value is somewhere between 10 and 20. You can't just say we have from 10 to 110. That's not okay because 10 is not necessarily what this value is. We don't know exactly what it is, and we don't know exactly what the highest value is. We just know it's somewhere between 100 and 110. So if we were oops, I meant to get an eraser. If we were to do this, what we would need to say is that our range of outcomes is somewhere between 10 to 20 to 100 to 110. And don't freak out about the closed bracket parentheses stuff. I like to make sure you understand what it's supposed to be, but on a test, if you have them wrong, it doesn't matter. I don't care. I care more about your interpretation. Now, in this particular case, we could do better than this because we have the ability to scroll back up, look at the original data, figure out who that really terrible student was who got a 14, and figure out who our best student was, which was 101. So we could actually get better than this and say 14 to 101 if we want. Oops. To 101 if we wanted to. All right, and then we got our shape. Any unusual observations? Does it appear like people have more values on the lower end, higher end, middle of the range? What we're going to do on the next page is get the 3 different definitions of shape, which we talked about in class. So I'm going to just skip that next page. So there were 3 pieces to our shape. And this, by the way, is something you may be expected to do on an exam. Just the shape portion. Not guaranteed, but it's something I've asked before. So you need to know what these 3 parts are and then how to interpret them. So how many modes? What's our symmetry look like? And is there anything unusual to talk about? So in terms of modes, how many humps does this have? This is something where students will get distracted. So let me erase some of this extra crap that's written all over this. A lot of students will tell me that this is bimodal because they'll sit there and they go, well, it kind of goes up here and then it goes up once more here. So it's a bimodal. I disagree on that one. You got to think more like a statistician, which is to think there's going to be variability. If you chopped this one off and threw the 3 over here, it wouldn't be bimodal. So one observation should not make something bimodal. That's thinking too strictly. So what you want to do is sort of just be a little more, like almost blur your eye and just say, what's the overall thing that's happening? This is kind of the overall trend that's happening. We have a single mode. So in terms of our modes, single mode would be unimodal. Symmetry is all about whether or not things fall evenly away from our mode. And we can see here our mode has a lot more stuff tailing off to this left side. And remember, the side of this tail, that's what tells us which way we are skewed. So in this particular case, we are skewed to the left. And then our unusual observations, well, nothing terribly unusual to call out here. There's no gaps. We could call out our really low score as a potential outlier. That's possible. And so a lot of times, if you're talking about unusual and this is a test and you don't think anything here is unusual, you'll just write there are no outliers. There's nothing unusual going on. Otherwise, you might want to call out possible outlier. And we don't know. We'll eventually get tests and we can see if this person's an outlier or not. Possible outlier at either 10 to 20 if you just have the histogram, or 14 if we have the true data. So you might want to call it that person who got a 14 is like, that's unusual. Especially considering that the mode is 90 to 100. This person is very far away from the majority of the students in the class. Oh, and that's another thing. I'm sorry, I just thought about it. When students see the word outlier, they tend to think about unusual. They're like, oh, this peak is unusual. It's not about the peak. It's about the observation and it being away from the majority of the values. So when we're talking about outliers, don't look at the actual height of the bars. Instead, look, where's the majority? What values are to the extremes, left or right of that? Do I want to call them out as potentially being problems? So that's all your stuff for shape. So we're going to skip this next page because I filled this out on the previous page, and all of this you can just read, and we'll get to this exercise. There is one definition here. Should have given you a space before, but approximately normal is a way that we talk about something that is unimodal, symmetric, and bell-shaped. So anything that has the little bell curve is approximately normal, as long as it's close to that. So for this next one, you've been given a histogram with wind speeds and their frequencies, and you're asked some questions. This is very much like an exam question. So take a moment, pause the video, and come back. Okay, so first question we're given is what percent of speeds were between 30 and 50? Now, this is when all that sort of cleanup that I talked about can be very helpful. So when I said cleanup, this like off-center screen is going to drive me crazy. I'm going to try to fix this. I fixed it. So what I like to do is first thing, just add in all of those numbers in between, just so nothing crazy happens. You don't tell me that there's an outlier from 0 to 10 or anything weird. I just put them in there so that way nothing funny happens. I'm also going to put in the actual frequencies at the top of these, sort of turn my histogram into a frequency table. Just make life easier. 4, 5. On a test, make sure you draw things over and double check that everything is right. If you want to check to see if these numbers are correct, I always give you the total number so that you can just go ahead and add up these things. Just like in the example with the test scores, they should all add up to our total number, in this case, total number of days that we're looking at wind speed. And that's your check. I didn't screw anything up. Very frequently, a student will make a mistake where they just off a number. If you write down what your work is, I can give you lots of partial credit. If you don't, and you just give me a percentage, do it in your calculator, I can't give you any partial credit. So show work. First question asks, what percent of speeds were between 30 and 50 miles an hour? So you should have come here and said, okay, here's 30. Here's 50. We are interested in everything in between 30 and 50, right? That's exactly what it's asking for. So the number of days, well, there were 3 between 30 and 35, 6 between 35 and 40, 4 between 40 and 45, and 5 between 45 and 50 out of all 43 days. And that's really nice that you're always going to be given that amount, so you can just bring it down. So this is it. We got 18 over 43. We type it in a calculator. We figure out what it is. But again, most common mistakes I see on these on the test. I'm going to go ahead and turn this into a percent. The most common mistakes is this being off a number or two in that numerator. And if you don't give me any work, I can't give you any partial credit. A very common thing is for students to just include one too many bars as they're adding up. So do yourself a favor on the test and draw those big lines in there so you know exactly what it is that you're doing. Okay, next one. What percent of speeds were above 60 or below 20 miles per hour? So above 60, there we go, everything this way, right? Below 20, everything this way. So we can see which days actually fall into this. We got 2 over here below 20. We've got 5 above 60. And so since it has a nice or, I've had students before say, well, it's not possibly both those things. Or means either of them. So we have 7 days out of the 43 where this happened. Either really high winds or really low winds happened. So 7 out of 43 is 16.28%. And our last piece here says describe our distribution of wind speeds. Okay, so our distribution, again, 3 pieces to the, it just says describe the distribution. Ooh, we got to do all of it then. So this is not what I usually do on the test. On the test, it'll just say describe the shape. Remember all 3 aspects. This does say describe the distribution, so I'm going to do all 3 pieces to that. So we need to talk about the center, the spread, and the shape. Center, well, the most common outcome, our mode, is from 50 to 55. Our spread, 0 to 5 to 65 to 70. Again, we don't know exactly what the miles per hour are, so we can't do any better. Our shape, unimodal. Again, I can see why you might say bimodal, but again, think if I just tipped one over, that wouldn't be the case. Still skew to the left, just like our last example. And we definitely have some unusual stuff. We have an outlier at 0 to 5 miles per hour, and I should have put units on everything, and a gap from 5 to 15 miles per hour. I am out of time, so I'm going to finish this up in the last video.